Now see the most important part of Java in object-oriented concepts. We call it as OOP, object-oriented programming. The very main focus part is on objects and classes. The very first term which you can say Java introduced was objects. Why we focus on object is because in object-oriented we design programs. Whenever we write a program or try to define a concept at an architectural level, what we use is we think of objects and classes, right? Now why we go for objects? See, whenever we write a program or define an application, there is a conclusion that this will be used somewhere in real time, right, in our daily day-to-day life. So for that purposes, what we do is we try to identify it as an object, right? Let's see more clearly in next slide. Let me define an object in Java is the physical as well as the logical entity. Why I'm mentioning both? Physical, your software and hardware will be dealing with those both entities, and whereas a class is a logical entity. Class means you're writing a program, right? So that will be a logical entity. But when you create a reference for those objects, both your class and object will be physical as well as logical entity. So treat object as physical as well as logical entity and class as only logical entity. You'll get to know when you start writing your programs in Java why we have defined object as physical as well as logical and why class as only logical, right? So let's see something about you can say objects. Here you can see we are having an object, right? It is a pencil. Can anyone define me the, you can say, state and behavior to define this object as pencil? Right, because my computer is not aware of what actually I am going to build up, right? So what I need to do is I need to well define this object to the program first. So how will you let know your program that what kind of class, method or variable you are going to use? So can you tell me the attributes of this object? Yeah, anyone can reply in the chat box. Very good. Shubham said color. Yeah, size, length, very good. Yeah, lead size, color, good. Okay, graphite quality, brand. Yeah, that's also a good point, right? So these are different attributes of an object. Now your object is coming into existence, right? You're having it a physical state rather than a logical state. So this is how we try to bridge up a physical entity into a logical entity. So objects depend on both attributes to be defined in the physical state as well as in a logical state. So we'll take some more objects. Might be an apple if I want to define it, that how good an apple could be. It might be of green color, red color, shape, size, whether it is of good quality, low quality, about its price, and so on. I can have many attributes. To define a book, I may have its author name, number of pages, the edition year, who has published it, in which year, right? Its price, and so on. So this will define the object. The more you define your behavior about that object, you're more clear about your program. So moreover, what you see is that your object will be having three states. About states, you can talk about as state and behavior. As mentioned here in the first slide, I have stated here that a definition of object is that an entity that has a state and behavior is known as object. So how we define an object, right? An entity. Why entity? Because I'm not yet recognized whether this is a pencil, apple, book, bag, or a blackboard, right? Depending on the attributes what are being specified, I'll be identifying that whether it is an object or something else, right? So what I need to have is two things. That is first state and second is the behavior. Now, if I collect those attributes, I need to tell it to the compiler, right? To the machine that this is the object and these are the logical attributes to be applied via programming. Right? So here, third part, that is the identity comes into existence. That's why collaboratively we can say that an object has three different characteristics. So first is state, second is behavior, and third is identity. Now what state represents? It represents the data of an object, right? Whatever we have seen right now was the data or the value. How many pencils were there? There were 3 different pencils. How many chalk were there on the blackboard? There were 2 different chalks, right? Might be different colors, different size. There was 1 duster. So this is what data is. It is defining how many number of the object is having the attributes. Second is the behavior, right? Behavior in sense, you can see the functionality of an object. Suppose if you are having a bank account, what will be the functionality of that bank account? Can anyone tell? If you are having a bank account, what will be the behavior of that bank account? What is the purpose of it? Basically, it is a logical entity, right? But what different functionalities do you apply when you have a bank account? Very good, Palak. Yeah, saving, you have current account, you withdraw money, you deposit money, you provide your checkbook, you check your balance, right? So this is how your data will be functioning on different attributes. Now, if I want to check my balance, I need to define a method, and a method is always defined in a class. So class is an entity with different attributes, right? My account name, my account ID will be constant. It will not be variable. It will not vary, right? For every transaction, I won't have my different name and my different account number. So these constraints will be constant for my single account. I may have multiple accounts, but those will not be interlinked, right? The information will be divided separately. So this is how your data is and your behavior is. Now, if I've defined it with my real-time entity where I will be depositing my cash or withdrawing my cash, right? So via a program or a software application, I'm trying to deal a transaction with 2 persons sitting on some location A and location B, which are not meeting face to face with each other, but still they are having a transaction successfully between object A and object B, right? So its state is to withdraw money, to deposit money, right, from remote locations. Now these terminologies I need to tell to the compiler that if a person is trying to withdraw or deposit money, this method has to be invoked, and you need to take that data and do the functionality, whether it is depositing or it is withdrawing, right? So these combination to deal with, to synchronize with the state and with the behavior, we need identity, right? So it is used internally. We do not have to be focused on this. We need to define on state and behavior. Okay, so identity is nothing but it is used internally by the JVM. JVM we have talked about in last lecture, the Java virtual machine, right? What it does, it tries to identify each object uniquely. Now, if I am talking about withdrawal and deposit, there will be at least 2 objects. One object representing the deposit, second object representing the withdrawal, right? So if I'm clicking on object 1, my method of withdraw will be executed. if I'm clicking on object 2, my second functionality within that method will be executed, so that the compiler or the JVM internally will be clear that what the user wants to do. Okay, so this is how you define your objects and classes. So there's a notification of last 10 minutes. If the session ends, you join with the same link again. Okay. A little bit about, you can say, objects. You can say object is an instance of class, right? So while defining an object, there are different terminologies about defining it. As we have seen here that if an entity, any entity has a state and behavior, we call that entity as object, right? This is one terminology. If you find it on internet, they will be finding many of these. So just to be aware of different words, different terminologies. An object can be defined in various terms, as in an object rather than a state and behavior can also be called as a real world entity, right? The similar words, right? An object can be a runtime entity, right? If I'm having an account of withdrawal and deposit, I do not know what amount to be withdrawn and to be deposited. That will be decided by the user at the runtime. So I'll be taking that input and then going for processing, right? There will not be a static value, a fixed constant value that so and so amount will be deducted and will be deposited, right? So that will be a runtime entity. Thirdly, you can say that an object is an entity which has both state and behavior. This is one of the, and it can have, it can be treated as an instance of class, right? So these are the different terminologies of defining of what an object is in Java.